So for your warm-up, you were given a sheet that looked like this. Okay? Right? And you were to use a random number table. How you assign your numbers to this, to do the table, I don't care. I probably would have either gone across or down. And you use then your number table going from 1 through 16 to pick random positions. And then you were to come down here and look at this, grab the values that corresponded to those, and then calculate your average. Did you all do that? If you did not do that, please take a second to do that. And you were to do that for each 1, 2, 3, and 4. So what I'm going to do, I'm going to kind of mix it up a little bit. This says to graph the results. You're welcome to graph the results from the class like this, but I'm just going to try to broaden your frame of reference, different types of displays that we could have, and I'm actually going to do this in what's called a stem and leaf plot. Looks just like a dot plot when I turn it sideways, but it tells us a little bit more. So I'm going to go around the room, and I'm going to ask you guys for your 3 different averages. So, Matthew, did you get yours? So, excuse me, just take it out to 1 decimal for me. So you got 6.8. Okay, let's go to Sarush. Okay, Gleb. A lot of very similar answers here. A little bit tighter than I expected. Please tell me somebody got other than like 6.5, 7.5, 6.5, 7.5. Because this is kind of crazy. It's not how it's supposed to be. 7.5. There we go. 7.3. And then 7.5. Okay? Okay, behind Gleb is Ashley. 7.6, 7.5, 8.2. Thank you very much. So coming up front, Malia. 7.8, 7.6, and 7.3. These are not the results we were supposed to get. Ah! Go for it. 6.9. Okay. There we go. Thank you. A little bit more. Spreading this out a little bit. It's me. 10.3. Awesome. There we go. Really crazy number. So, hey, up. I didn't go that far. So you got 10.3? It's possible. Hang on. I started writing this wrong. 10.3, what was the next one? 8.5. And 6.5. Okay, all the way in front, Brendan. 8.5. 5.5. And then 8. Now we're starting to get more of a spread that I'm looking for. Go for it, Eden. 7.3. 7. Oh, that's over here. Running out of room. And one more time. Guys, I can't hear when other people are talking. Okay? Kyle, are you finished? I see you working. Okay? Okay, thanks. Having to bend my thing over again. I wasn't expecting that many. Right, next is going to be Kaylee. Sure, no problem, Julia. 8.6. Okay, back into the front, Carissa. Predictable much? A little bit there. Anna? Okay, behind Anna is Abigail. Okay, next, Cameron. Okay, and then behind you, Ryan. 8. 8 again. Woo! Eee! Is that even a possible? Yeah, that's not possible. Yeah, and neither is the 10.3. The average, what I was asking you to do is randomly pick from these and then find the average of them. So you're to pick 4. And if the smallest number here is 5.1, so Smeet, also you. So did you mess up on all of them or just that last one? Can you tell me what your other numbers were so I can erase them? They were both 8s. Okay, we'll come back to Ryan. We'll come back to Smeet. So that means we are up to Ronan. 8.9. 7.6. And 7. Okay, behind you is Kayla. Okay, behind Kayla, Carissa. Caitlin. Dude. Yep, that's possible. Okay, Jackson. Okay, Samantha. Okay, and Avni. Okay, I know where that goes. That's where that goes. Okay, Smeet. Uh-huh. Okay. 8.3. Okay, and Ryan? Yes, sir. Okay, so what is this? What did I graph? Do you know what that's called? Stem and leaf plot. And then typically for a stem and leaf, you will see something like 7-6 is equal to 7.6. So it means you have a key. And then typically when you do these correctly, you arrange them from smallest to largest. But what's nice about the stem and leaf plot that we don't get with the dot plot, I can tell you every single data point that was given through this. And you can break a stem and leaf plot so that you don't have to write it in terms of integers by simply saying from 5.0 to 5.5, not including 5.5, I'm going to write those numbers here. Starting with 5.5, I'm going to write that decimal here. Okay, so it just breaks your things up. This was a little bit more tightly clustered than I was expecting, which is awesome. But these are the guys that we had. Okay, so which method do you think was best? Stratified by row? Why? Because if we look at our numbers, as we go further and further away from the stage, we had a worse and worse experience. So if we stratify by row, we randomly pick a row and get everybody in that row, we get a better, or stratify by row, get one person per row, you get a better representation of all the different things when you know that what row you're in is going to be the biggest factor. Okay? Could I have done a cluster sample with this? Sure, how? Weren't you the one that said sure? Yeah, how? Absolutely. You can split these up and say, if I want to do a cluster, there are my 4 clusters. Nice and easy, and you can pick one of those. What would be a problem with a cluster sample? Yes. Right. Again, it's that same idea with big differences between the front 2 clusters and the back 2 clusters. So that's too much of a difference. We're only going to do clusters if, for example, I had a good variety in each of those clusters. Then it would be okay. How could I have done a convenience sample? Just do 1 row. As they walk out, how did you feel? Or grab that 1 row's data. What would be bad about that? Yeah, every row is completely different. We think the rows played a big part. So if I were to do a convenience sample and just grab everybody in 1 row because it's easier, you risk getting a highly skewed point of view from your participants. Okay? So what was nice about this activity is it really gives you a chance to kind of see what doing different things will do. And if I look at each of my different graphs here, do you think I want to see more spread out for my averages, middle, or tightly clustered? What do you think is good? What do you think gives the most accurate representation? The middle one. What we call with that, when we have something that's nice and peaked mostly like that, when it's all tightly clustered, we say that that has low variability. And I don't need to cross an L, I just need to dot my I's and cross my T's. Low variability means good predictability. Okay? Low variability means I'm not going to have a really wide spread of answers, and I'm going to be able to have a good prediction whichever one we do. Yes, it's possible to get more of these outliers, but it's less likely to occur. And actually, I don't think those were actually possible for this one. Yes, they were. Okay. All right, so there's that. What we're going to be talking about today is, back to the PowerPoint, we're just practicing. Because this is one of those things where I really believe that there is so much vocabulary in this unit, you don't really understand it until we start pulling it apart and trying to apply it. Which is why you had the video with all of those words in it. Was that the most entertaining video in the whole wide world? Thank you for being honest, Caitlin. She's like, no, this was horrible. Listening to you read definitions from a screen. Wow. But you needed to have time to get those. That way, what we can do now is do some problems. So just flip your note sheet over. And all we're doing for this part here, for example, 11.1, all you're doing is reading through and you're defining the sampling strategy. I have trouble with that word. I have trouble with a lot of words. Strategy used in each of them. Okay? So you're going to go through those and you're going to figure out which type of sampling method was used. So go ahead and do that. Just write down the words that go for each of those. You're welcome to talk amongst yourselves. Do whatever you'll need. All right, so as we go through these, what did you get for A? What kind of a survey is that? That is a cluster. Good. Why aren't we moving forward? There we go, cluster. For B, symptomatic. Symptomatic? Systematic. Symptomatic? I mean, interesting way to select people based off of your symptoms. Okay, so B is systematic. Systematic, by the way, does have a piece of randomness in it, and that's going to be the starting position. So like randomly pick the first one, and then you do every fourth after that. Okay, so don't think that there's no random involved in there. Okay, for what about C? Stratified, because we've identified groups that we think might impact the final answer, and I'm going to make sure that each of those groups is represented. Happy word day. I don't do good. Okay. All right, and D. Simple random sample. Can somebody define for me what a simple random sample is? I don't care if you're looking at your notes. It means you actually have it written down someplace. Carissa.
Size n, so it's like your sample, and then set up n elements in the sample so much.
Good. The big thing I want to make sure that you understand is for a simple random sample, it is not about the individual. I don't care about the individual. We care about the groups, because statistics is all about looking at a group and using that to glean information about the whole population. So a simple random sample is not that every individual has an opportunity to be selected, but that every group could be selected. So it's completely possible to get nothing but part-time clerks. Hopefully it's not very likely, but it is possible, which is why when we saw our simple random sample scores, when we were looking at the warm-up activity, we did still see a pretty big spread, because anything is possible. Okay? So, keep going through these. 11.2, 11.3. Use your words. Now, on some of these problems, you guys can obviously get different answers for this, especially since you're not given, well, you were given a random number table, but even with that, depending upon how you choose to go through and number your people, things can be different. When we're looking at 11.2, so we're going to go to just the stores in the city close to the headquarters, so you don't have to travel far. What type of sampling is that? Yeah, that's convenience. I mean, you might be able to argue cluster, because those would be clustered around the city. But generally speaking, your reasoning behind this is I don't want to drive too far. That's convenient for the folks doing the survey. Okay? Why do you think that would be bad? And there's all sorts of different answers for that. Were you raising your hand? Okay. Why would that be bad? You can just make stuff up here. If you can justify it, it's probably good. Okay, so there you go. Close to headquarters, you could argue that that might be in a really nice area, and therefore the stores are going to be different than the ones that are in further spread out. Ryan? Okay, they might get more attention. What do you think more attention would do to a store? Right. If you're right down the street from headquarters and you know someone's going to be popping in a whole bunch, you're probably going to be better behaved than one of those stores out in the middle of nowhere where nobody ever comes to check on you. And you're like doing cartwheels through the aisles and nobody has checked inventory for weeks. And it's like, woohoo, whatever, free for all. Please don't ever do that in your job. That would be bad, by the way. Anybody else have another reason why? Because again, with this, if you back up your justifications, there is a plethora of reasons out there why you might think that being close to headquarters is going to somehow skew your results. Okay? And what kind of bias is that? Convenient sampling is its own bias. Convenient sampling often results in undercoverage. Undercoverage is like a really kind of catch-all. If you know that you're only going to be getting certain types in this one form of sampling, usually it does result in some form of undercoverage. Undercoverage is like the default. If you can be a little bit more specific, then absolutely be more specific. But undercoverage is kind of that overarching umbrella. So here we've got undercoverage might occur. Convenient sampling results in undercoverage. Employees may not be the same as in other areas. How so? You always want to justify this because remember, this is all about context. So, they're just going to be different and leave it at that. Give me a reason why they might be different. And here's something that nobody mentioned. It's in the city. Cities are bad. Lots of drugs and violence in the cities. So if we're doing this, then there might be a higher occurrence of drug abuse. Okay? Or all the other reasons. What I'm trying to get you guys to see here is there's not necessarily one correct answer. This is the beautiful and the frustrating part of statistics. You really have to kind of take your brain outside of the little box that you live in and think about how it affects others. Okay? So here we have 20 full-time clerks. It says use the random numbers to select 4 of them. Clearly explain your method. Somebody wanted to start telling me, what do I need to run this sample? What do I need to do to select my people? Pick my people now. How'd you pick your people?
I assigned random numbers. So I assigned Larry with 0, 1 all the way to Aaron out straight across. So I assigned 20, and then I went to the table.
How simple is that? That's one really nice way. You can say, you know what? I have 1 through 20. And you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go up and down. You can go left to right. 1, 2, 3, 4. That's possible. But what happened if you pulled a number like 36? You ignored it. Okay. So what you have to be specific here is if you're only assigning the numbers from 1 through 20, you have to tell me what to do with all of those other numbers. Because this isn't your calculator. Your calculator, you can say, I only want these numbers. But in the table, you say, I'm going to ignore numbers 21 through 99 and 00. Okay? Or, anybody do it a different way so that there was nothing left out, no numbers left out? Anybody? Anybody think of a way that I could do this without leaving any numbers out? Okay, so how could I assign 5 numbers to Larry? So if you're going to start with 0, 1, 0, 1 to 0, 5, 0, 6 to 10, so on and so forth. Or 00 to 4, 5 to 9, so on and so forth. Is there another way that you could have done this? Obviously the answer is yes, otherwise I wouldn't be asking. But there's several different ways. You can say 1 through 20 and then start all over again. 21 through 40, 41 through 60. And you can do what's called modular math, which is a really cool thing. Basically all it is you find a 2-digit number. You keep subtracting 20 from that until you get a number between 1 and 20. So if I had 86, I would subtract 20, subtract 20, I got down to 6, and 6 would be Josh. All sorts of different ways. There's one more thing that I needed to know. Anybody guess what we've left out that's really important? Are repeats okay? No. I am not going to drug test Larry twice. That would be pointless. Unless you're really, really, really wondering about if Larry is cheating. And you're like, okay, the first time was just to get your guard down. Now I'm going to really test you. So what I've got here, you want to make sure that you clearly indicate, this is very much like a simulation. How many digits are we talking about? 2 digits. And it says use the random digits in groups of 2 to select the first 4 people in the sample. Ignore numbers 21 through 99 and 00 because there are no corresponding people, and ignore the repeats. How many digits? Very important when you're talking about given a table. You need to tell me how many digits am I looking at a time. How are my digits assigned? What about the numbers that I'm not using? And then repeats. Okay, so what I ended up getting from mine, I got Andrea, Matthew, Marissa, and Brian. Kyle, if you need to stand up in the back of the room, go ahead. If you need to stand up in the back of the room to stay awake, go ahead. Okay? All right, so what kind of bias would I get if I hold department meetings and drug test the employees that attend? Why might that not be the best way to drug test your employees? I keep getting the same two of you. No, I want somebody else. Yes. Uh-huh. Okay, why? Okay, but why is that a bad thing?
It's not really indicative of everyone else who doesn't attend, and maybe the people that don't hold those type of positions won't get tested.
Okay.
I said voluntary response bias because people can choose to show up, and people that take drugs probably will not.
Got two different types of people there. The people who actually show up to department meetings or to staff meetings are a certain type of person who is pretty much on the ball usually. A little less OCD, overly cute disorder people. It's like everything has got to be right. Those probably less likely to be the drug givers. And undercoverage, absolutely. And undercoverage is always going to be the thing. The problem that people have is they have an issue with voluntary response and non-response. That's like the hardest ones to keep straight. But what you need to understand, and I like the way that you put it, Cameron, I like the way that you said voluntary response, people are choosing to go to it. If you're doing a sample or a survey and you're saying that person gets to choose whether or not they participate, it's like if I am doing watching the news and they put up a Twitter poll. That is always going to result in voluntary response bias because only the people who feel strong enough to actually participate are going to participate. Whereas non-response is like what happens when we do the U.S. Census. Every single person gets what they need to participate in the survey. Ample opportunities. Or like those robocalls. Those are going to result in non-response because the survey or the sampling come to you and you choose not to participate. Or you did not have that ability to participate because you weren't at home. But no matter what, the survey is coming to you. That's the difference. Do you see how there's a little bit different? Voluntary response, you choose to go to the survey. Non-response, the survey came to you, but for some reason or another, you did not participate. Okay? So, yep, it's definitely a convenient sample, and you can say under. And under coverage always kind of goes hand in hand with over coverage, because if one group is underrepresented, the other group will be over. So I don't really care. And again, we're just looking at the ones that show up. Notice how I did not stop at just the words that I'm claiming that this kind of this kind of bias is or this kind of sample is. That is not enough. You must always back it up with some good found logic. Okay, what if I offer additional employee discounts for those employees who agree to be drug tested?
It's a voluntary response bias because people can choose whether or not they want to be drug tested, and then employee discount probably isn't worth it.
Beautiful. Absolutely beautiful. Word for word, I loved it. Voluntary response because you're still volunteering to kind of participate in this. And it's going to result in undercoverage because those people who are doing drugs probably going to weigh the benefits of a discount versus a job.
I said response bias because response bias is anything in a survey design that goes with responses, and the employee discount is.
If we're doing like a drug test, is a bonus going to alter your results from the drug test? No. So you've got an idea there. You've got a good idea saying that, okay, if we're kind of being bribed, if it was just like random questions, and it was like, what's your opinion? It's kind of like saying your boss is lording over you, saying, I want you to write your opinions of me as your supervisor now. And he stands over you while you do that. This is a wonderful job. I love my job. Please don't fire me. You're going to get different types. But if it's something like this, where the main focus here that we're looking at is the idea of drug testing, it's not going to alter your response. Otherwise, I would have said absolutely. Okay, so again, voluntary response. And yeah, unless you're like really high and you're not thinking and you're going, yay, discount food. And you don't think, I'm on drugs, I'll get fired, there will be no more food. It's probably going to cause an issue. Yes, ma'am.
So, on
The notes,
So, being sample is listed under bias. Would it ask for that?
It's both a bias and a sampling method.
So, would we have, like, if it asks for bias, would we just say it's convenient sampling because, or should we say convenient sampling which causes undercoverage or something?
You do need to address what, like a bias. And so you would say it's convenient sampling. And usually, so that we don't say it's convenient sampling, convenience bias, we want to kind of mix that up a little bit. So we would say convenient sampling undercoverage. And that's the problem with convenient sampling. Yes. Pretty much. Okay. All right, here we go. Now we're going to just kind of talk a little bit more on your flip book. There is a little, I love that you've got it out here. I'm going to hold it up. There's a little box that's empty. That's still in that box, but I'm giving you a heads up. The order I'm going to pull it up on the screen is not necessarily the order that's on here, so pay attention. Okay? So, what you need to understand, and we're going to keep going back and forth from this all year long, and I want you to kind of listen to the words. Population parameter. So a number that reflects every single person, every single element within my sample, the actual average GPA of a Battlefield High School student, the actual average weight of a baby at birth. That is a parameter, population parameter. Whereas when we take samples, we have statistics. So we've got a population is to a parameter as a sample is to a statistic. Okay? But there's a nice little hint that rolls inside of all of that. What do you hear? Population parameter, sample statistic. There's an alliteration, yeah. Because you got population parameter, PPs. Sample statistic, SS. Okay? So when we're talking about everything, when we know the truth about every single individual, not very often, that's usually a census or if everyone had to register for something, then we call it a population parameter. If we're trying to estimate based off of our sample, we call it statistics. Hey, what class are you taking? Are we taking parameters? AP parameters? What class is this? Yes, I'm just trying to be silly here. Wake up. AP statistics. Because the purpose of this class is to be able to try to make inferences, to make an educated guess based off of a small group about the whole population. That's our class. So, when we're talking about populations and parameters, our notation is a little bit different so that we can distinguish quickly between which group I'm talking about. So we use Greek letters to denote parameters, and we use their Latin equivalent, basically your alphabet, when we're talking about statistics. So here's our table. You do not need to write out how to pronounce these things, but please pay close attention to what is in which box, what order it goes. For mean, a lot of times what we'll talk about is either X bar or Y bar. Literally, it is an X or a Y with a bar over the top of it. And that is that's how you read it, X bar, Y bar. That means the average of all of your samples Y. So each sample will be a Y. You take the average of all of those. Whereas the actual population parameter for average is called mu. Not mu. Mu. And if you guys will look up here, I will show you how to write that letter. Or actually here, I'll even come down here. I'll do it this way, so that everybody stops and watches. When we are talking about y bar being the statistic, the parameter, watch how I'm writing this. I'm trying to make sure you can see it. Is that. Sometimes you will see it written as that. It is not an M. It is not a U. It is a mu. I like how that works out. If you give me that, you will not get credit for it. If you give me that, you will not get credit for it. You must give me either this or this. And again, it's just like you're doing almost a cursive U. And sometimes they'll take the U a little bit higher there. Okay, so you have to make sure you understand how to write the symbol for mu. Okay, so that's the symbol for mu. That's the average of a population. Standard deviation, we call S. Kind of, sort of. Standard deviation is an S. This guy here is a sigma. You guys know what that summation symbol is, that big E? This is a lowercase version of that letter. I know, they're not related at all. How am I supposed to write that? See, I hear things. All right, let's show you how to write that. To write the sigma, and a lot of times for standard deviation, they might say the standard deviation of all of your observations X or the standard deviation of all of your observations Y. But when we're talking about sigma, watch how I do this. There's a couple of different ways that you can write it. Some people do an O with kind of a hat coming off the end. I kind of do it like a T. I go straight down, arch up, cross over. So I don't care if you're going to do, again, a circle with a hat on the top, or if you want to straight down, arch around and over. They're basically the same thing. But that is sigma. That is the lowercase of that guy. They look so much alike, right? What? Yes. Okay, so that's sigma. Correlation is something that we are not going to talk about in this class until almost the very end. So do not use the word correlation. Consider it one of your 4-letter words with a lot more letters than that. Correlation, when we're talking about a statistic, we see R. And when we're talking about a parameter, that's a row. And to do a row, it isn't a P. I know, it's like, wait, how am I drawing these things? The row is like kind of doing a spirally hook. So you can connect it, but I do not want a straight up and down with a circle attached. That is not a row. That goes with correlation. That is the parameter that matches with correlation. These two, not right now. The other three, yes. The correlation and the regression coefficient. Those two, we are going to be dealing with again to the very end. Otherwise, we're going to be talking about these three all the time. Okay? Regression coefficient is a B for the statistic, and this little guy is actually called a beta. The little footnote here, because I love our textbook and it's funny, is unless you learned it in England where they call it beta. Really, that's what they call it. They call it beta. Or if you do any English colonized countries, beta. Just a little new thing. And then proportion. Proportions look very similar from the statistic to the parameter. This is called a Y bar for mean. For proportions, that is a P hat. Quite literally, P hat. That is the name for that little caret symbol over the top. P hat. And just in case you didn't know how to pronounce P, it's P. Just in case you didn't know how to pronounce that. And I know how frustrating P and rho are so very similar to each other, but that's why I kind of emphasize how you draw a row. Okay? So again, right now our main focus is on mean, Y bar versus mu, standard deviation, S versus sigma, and proportions, P hat versus P. Okay, so basically what we're doing in statistics is we grab these guys and we hope our sample statistics describe the parameter. The closer it is to the truth, that's what we want. And that's why we have all of these different sampling techniques, what we saw from our warm-up. They result in different closeness to that actual value. All right, so when you're going through this, if you wanted to complete a survey of all of the students in the county, the whole county, Prince William County, I wanted to sample all the students. How could I do an SRS? Is that possible? A simple random sample of all of the students in the whole entire county. How could I do that? What do you think? Shnimana Herma? Student ID. What would I do with their student IDs? Yeah. Have a random number generator. Generate student IDs. And assigned. Pretty simple? That's, yes. Yes, it's just that's what their student IDs already are. So like if you wanted to start over from 1, you can do that. Absolutely. But that's why we have student IDs. And sometimes if you're looking at an Excel spreadsheet, so you can get an Excel spreadsheet and you can have a column that says student IDs, but then right next to that, each of your rows typically has a number assigned to it. You could even just generate it by row number. Okay? How would I do a stratified? There are lots of different answers here. How could I do a stratified sample on all of the students in the county? No, not you. Randomly pick a set of students from each school. Good, because she's identifying the fact that I think school might have an effect on whatever I'm talking about. You can group by grade type. Beautiful, because again, I probably wouldn't compare you to a kindergartner. I think that might offend. Yes. You can group even more specifically by grade level. How else? Yes. Based on gender. Gender might, I don't know what I'm asking. Gender might play a role. What else might play a role? Toss the PC out of here, by the way. Statistics, they're numbers. Age, race, income. We talk a lot about these things in this class. They're not necessarily the most comfortable things when we've had it beaten into our heads so much that we don't want to judge you based off of these subgroups. But the fact of the matter is those different subgroups do affect certain things. They might affect your opinions on things, the types of jobs that you pick, how much money you make. Unfortunately, that is true. Okay? Cluster. How could I do a cluster sample? Pick one school, get everybody. How else could I do a cluster? Pick one grade level. Get everybody in that grade level. Somebody define a cluster sample for me. Yes?
A sampling design in which entire groups, clusters, are chosen at random. Each cluster should be heterogeneous, so all clusters should be similar.
Good. So if we think all clusters should be similar, like maybe I say, I'm going to pick, I've got them broken down by districts. Because the schools generally within the districts are pretty similar. And then for each district, I'm going to randomly pick one school. So I've identified my clusters and I pulled randomly from those clusters. Okay? So neighborhood, based off of school. But again, the idea with a cluster is you're identifying what your groups are, but it's not necessarily saying I'm going to get everybody in that group. Systematic. How could I do a systematic sample for all of the students in the county? Sweet. Ooh, there you go. Take a look at student IDs. Everybody with odd or even. You can kind of like extend on that, right? Anybody whose student ID is divisible by 10, ends in a 0. I want you. Cut it down even more of a fraction. You can arrange all of your student IDs from smallest to largest and take every 60th student ID. Student IDs are really what you're going to start with. You can also do systematic sample by looking at a specific letter group. So I'm going to identify each letter group, and then I'm going to pick every 100 person. Basically, a system is saying that if you tell me what your starting position was, which is supposed to be random, I should be able to generate the exact same people that you did, or the exact same sample that you did. Okay? Okay. Thank you. All right, I want you guys to try this one problem, and then we'll discuss your quizzes. This is not a multiple choice question. Okay, so I'm going to speed you through this so that we can kind of talk about it. With a sample that large, we can be pretty certain we know the true proportion of Americans who think ephedra should be banned. What do you think about that statement? Yes? No. And the reason why I'm saying no is when we're talking about sample size, 17,000 is a really big number. We don't care about what proportion of the whole that is. We want a big number, and we actually don't want to go above 10% of whatever your whole proportion is. So the sample size itself is good. Okay. Okay, good. Is that what you were going to say? And that's basically what they're looking at here. When you have a sampling bias in existence, it doesn't matter how big or small your group is. It's not going to change the fact that you have a bias. So that's a really good number. If I took a simple random sample of 17,000, I would say, dude, more power to you. You got that many? Great. But the way this was collected was what kind of a sample? One more time. Voluntary response. People chose to participate. And there are things that are going to limit who chooses to participate. So size is not going to overcome that factor. Okay, so do you think the wording of the question is very biased? Why? Well, if 63.5% said yes. Hmm?
It's asking, should continue to ban rather than not like do should be banned at all. So it's switching to say should it keep going? Sorry.
Okay. This is all about your arguments here, by the way.
It also talks about how many deaths and heart attacks and strokes have been caused by it.
Okay. Kyle?
There's no word for it, so they say it's like dangerous.
Basically, that like lack of proof. It's all from an attacking standpoint rather than like presenting.
I can definitely see your guys' arguments. Let's go through it one word at a time, and I want you to tell me, is that a fact? Linked to 155 deaths. That's a fact. I'm assuming that's a fact. Any more heart attacks and strokes? Facts. Ephedra manufacturer claimed that the FDA lacked proof. Like if they went out there and their argument is they don't have proof. Fact or opinion? Fact. Lacked proof that it was dangerous if used as directed. Was it fact or opinion that they were denied a temporary restraining order? Fact. All of these guys up here, you might not like them, but they're all the arguable facts. These are what they're doing. The FDA is saying, these are the reasons why it should be discontinued. The company is saying, this is the reason why it shouldn't be. So for something like this is actually, and the fact that I put the word clearly very biased, that in itself is steering you to say, yes, it's biased. But the fact of the matter is these are all facts, they're not opinions. Okay? Sampling frame is all internet users. No, it's just the ones that participate. Can't be reliably. That's true. All right, so let me go to your quizzes real quick. I think one of the biggest questions was the last one on the front page where it was talking about the eggs. A lot of people said that I could do the 0 being no bad eggs, 1 being 1 bad egg, 2 being 2 bad eggs, and 3 being 3 bad eggs. And you just count the number of times you got a 0. But the fact about that is if I count a 0 and I get a 0 the next time, is that okay? It's this idea of repeats. When we're talking about the eggs, if I take one egg out, smash it! Hi. And I smash that egg to find if it's good or bad, stinky or sweet. Can I pick that egg again? And no matter if that egg was good or bad, the percentage of eggs left that are good or bad, has that changed? Yes, I've taken one out. If I've taken a good one out, that means I have one less good one I can go for. The percentage is not going to be the same. If it's a bad one, I now have a lot fewer bad ones left, so my probability is going to change as I go through. So that's why we say number the eggs. Let the numbers 1 through 3 be the bad eggs. So no repeats. Once I pull it, I can't pull it again because that takes care of the fact that my probability changes as I go through. On the back side, I talked to you guys about the fact that was graded on an AP scale. The biggest thing with this, you were automatically dropped from a 5 to a 4 if in your conclusion you said something will happen or something did happen, and this is what happened. And take this with you when you go into your investigative task that's due tonight. These are simulations. This is what I think over the long run I should expect to occur on average. So you need to be talking about on average what should occur, what we expect to happen. But this is not something that actually happened. This is a simulation that you're using to model real life. And so their biggest thing with all of this, one of their biggest points that they're looking at, that's the difference between a 5 and a 4, is don't confuse a simulation with reality. And you cannot say what will happen ever in this class. We're making predictions. We are not psychic. Even if your topic is ESP, we are making predictions. We are not psychic. So do not confuse a model with reality, and do not tell me what is going to happen. You can say what should happen or what we think would happen on average, but that's it. Toots Magoots, quiz next class.